Okay, so good morning, everyone. So, since we are modular today and we do not anticipate this setup, but because of the unexpected weather disturbance, um, we do not have a choice, okay, to take this step to protect, of course, the personal of DepEd and, of course, the most important, our learners. And for this, we just need to continue, okay, to continue delivering our lesson. That despite of the setup, we are still here. Okay, we're still here, willing to listen and willing to attend your class. So in this module, we will talk about the expanding universe, the historical concept, and other facts. Okay, seems fascinating, right? So this topic will discuss or will cover the different astronomical phenomena or events that happens in the universe, together with the development or how astronomy developed through time. Okay, so we will also discuss the different scientists who made an impact or contributions in the field of astronomy. So without further ado, let's start this lesson. So in this lesson, we will discuss four major titles or topics, which is the first one we have the shape of the earth. We will talk about the different theory about the shape of the earth. Second one, astronomical phenomena. And so we will talk about or we'll pick some astronomical phenomena that happened in the past. Okay, like for example, supernova, okay, the formation of our universe. And for the third one, the development of astronomy, of course. We'll talk about how astronomy develops through time. Okay, so how it starts. And then the last one, we will also discuss the Kepler's laws of motion. Ayan, so let's start for the learning competency. Okay, at the end of this lesson, you need to explain how the Greeks knew that the earth is spherical. Second, cite examples of astronomical phenomena known to astronomers before the advent of telescopes. And then the third one, explain how Brahe's innovation and extensive collection of data in observational astronomy paved the way for Kepler's discovery of his laws of planetary motion. Okay, so for the learning objectives, discuss what implications the law or the three laws of motion might have had on the world of science during in Kepler's time. Second, demonstrate understanding on the different theories of the origin of the universe through citing examples of astronomical phenomena before the invention of the telescope. And then the third one, display interest in learning about different astronomical phenomena during the ancient times. Okay, so the first question in this topic is, what is one astronomical phenomena that you find particularly fascinating and why? So in this question, you will give a fascinating astronomical phenomena that happened in the past or okay, in the present. Okay, pwede rin naman. Okay, so ano kaya yung mga astronomical phenomena na gusto natin or parang maganda, okay, or appealing. Okay. So, who wants to answer and volunteer? So, if you have your answer, just send your answer in the comment section below. Okay, so these are the different astronomical phenomena that I choose. The first one is the black holes. Okay, so black holes are fascinating astronomical phenomena that happens at the end or at the end point of the stars. Okay, so they are mysterious invisible objects in space that have a gravitational pull so strong that nothing, not even light, can escape. So their existence was first theorized by Einstein's theory of relativity, and they have been studied extensively by astronomers and astrophysicists. Black holes play a crucial role in the evolution of galaxies, and their study has helped us understand more about the nature of space and time. Okay, isa yan sa mga fascinating events or let's say medyo mysterious or it's like parang napaka-mysterious event niya talaga na ang ating alam lang if we're going to enter or pag nakapasok tayo dun sa black hole, wala na talagang escape. Yun lang yung pinaka parang basic na alam natin. But there's more than that. Okay, about black holes. Okay, so ito po yung picture ng black holes natin. Okay, next, eclipses. Okay, so eclipses, okay, one of the most rather fascinating events in the atmosphere. So eclipses are fascinating astronomical events that occur when the moon passes between the earth and the sun. So it means pag nasa gitna daw yung moon, okay, ng earth and sun, it is known as the solar eclipse. Or when the earth passes between the sun and the moon. Pag yung earth naman yung nasa gitna ng moon and sun, it is known as lunar eclipse. They have scientific and cultural significance. Of course, kahit nga sa atin, 'di ba, pag tayong mga Pilipino, pag may eclipses, okay, parang na-associate natin ito sa ibang mga superstitious beliefs. But in ancient times, ang eclipses ina-associate din nila sa, it's like, pag merong eclipses, parang ang sabi ng mga ancient people, it's a sign or a bad omen for them. Kaya ang ginagawa nila, nagkakaroon sila ng mga rituals, especially if napanood po natin yung Apocalypse. Okay, talagang meron talaga silang inaalay dati ng mga tao. Okay, kasi parang tinitreat nila yon as a bad omen, pero hindi naman talaga. And people have been fascinated by them for centuries. Talagang interesting event. Okay, at nakakatuwa naman kasi uh, in our present time, okay, meron na tayong malawak, okay, na kaalaman about this phenomena. Okay, next. Yan po, eclipses. Okay, so for the next one, meteor shower. Of course, ito yung favorite nating gustong ma-witness talaga paggabi, no? Especially pagkasama natin yung mga special someone natin. So, meteor showers are an exciting astronomical event that happens when the Earth passes through a trail of debris left by a comet or an asteroid. This causes small particles to enter the Earth's atmosphere and burn up, producing shooting stars. And meteor showers are named after the constellation from which the meteors appear to originate and can be a stunning sight to behold, producing dozens or even hundreds of shooting stars per hour. Okay, from the word meteor shower. Okay, di ba pag sa shower, pag tayo merong may shower tayo faucet sa CR, yung parang maraming tubig na nalabas yan. Okay, so dito sa ating meteor shower, parang umuulan ng maliliit na debris. Okay? Kasi ang ating mga meteors, okay, maliliit lang yan. It's like a size of pebble. Meron din namang mga mas malaki pa sa pebble. Okay. And, di ba nung na-discuss natin sa grade 8 yung konsepto ng meteoroid, okay, they are small like a pebble. Okay, so parang yung size talaga nila kasi laki lang ng pebble. And there are thousands of meteoroids that enters the Earth atmosphere. And if they enter, they are known as meteor. Okay, but okay, out of thousands meteors, so 1 to 20, okay lang yung nakaka-successfully land in the Earth's surface. And mostly karamihan pa sa kanila is nasa tubig bumabagsak. Okay. At kaya din natin hindi na-witness yung mga yan is mostly talaga or majority ng mga meteors nag-a-appear talaga sila during daytime. And bakit nagkakaroon ng meteor shower? Kasi, in the concept na yung Earth is orbiting around the Sun, umiikot siya, may mga cases na may mga nadadaanan tayong mga debris or leftover ng mga umikot din na comets or asteroid. And for that, okay, yung mga debris na yan, okay, pumapasok sa ating Earth atmosphere. Yun yung nga yung nagkakaroon tayo ng mga meteor shower. Okay, so ito po. Ayan. Next, the supernova. Ayan, so yung supernova naman is, syempre, associated lagi yan sa stars. But, it is a fascinating event. In our previous lesson, na-discuss natin na in supernovae, there are several important elements formed, especially yung mga heavy elements, which is a good thing. Okay, in supernova. So, supernova are explosive events that occur when a star reaches the end of its life and explodes. Okay, daran. They release an enormous amount of energy in the form of light and other types of radiation, creating heavy elements, just like what I've said earlier, in the universe and playing a critical role in the evolution of galaxies. The study of supernovae has helped astronomers understand more about the nature of matter, energy, and the universe. Okay, so ito po yung ating supernova. Okay, next, we have rotation and revolution. So, it's a self-explanatory naman, rotation and revolution. Okay, so rotation, okay, it happens only for 24 hours that causes day and night. And revolution, ito naman ay, it happens for about 365 days or 1 year. So, rotation is the spinning motion of a celestial body on its axis. Sa axis natin. While revolution is the motion around another celestial body. The study of these motions has helped astronomers understand the mechanics of the solar system and the universe. Okay. So, ito yung ating mga rotation and revolution. So, meron po akong question sa inyo. Okay, so do you think that planets is the only celestial bodies in the solar system that revolves around the sun? Yes or no? Very good. So it's a no. So hindi lang po mga planets yung nag-orbit around the sun or nagre-revolve around the sun. Even the asteroid, comets, okay, nagre-revolve din sila around the sun. And each of the celestial body has its own orbital period. Meron silang orbital period talaga bawat planets. Like for example, the Earth, ang orbital period niya is 365 days. Kumbaga para makakomplete siya ng isang ikot, ano yung ilang araw or ilang days? 365 days or 1 year. Okay, next. We have the phases of the moon. So ito namang mga phases of the moon, fascinating events even in the ancient times. Why? Since phases of the moon is used by the earliest astronomers to make calendars. Ito yung mga parang basis nila din. Okay, sa paggawa ng mga kalendaryo. The phases of the moon are the different appearances of the moon, of course. May mga crescent, full moon, okay, as seen from the earth, resulting from the relative positions of the moon, earth, and sun. As the moon orbits around the earth, different amounts of sunlight reflect off its surface, producing the various phases of the moon, such as the new moon, first quarter, full moon, and last quarter. Ayan, so very elementary na naman po yan. But we consider this event as a fascinating one, right? Okay, ayan po. Ayan, so, hindi lang po ito ha, okay? Hindi lang po ito yung mga fascinating events na nangyayari in the universe. Okay, marami pa. But, I only choose this one as one of the best for me. Okay? So, next. For the next question we have, what do you think is the most significant contribution that astronomy has made to our understanding of the universe and how has it impacted our lives? Ano kaya sa tingin natin yung pinaka-importante or the most important contribution of astronomy in our lives? Okay. So, okay, so this is the answer. The most significant contribution of astronomy is the discovery that the universe is expanding, which led to the Big Bang Theory. Okay, so itinitreat ito ng science as one of the most important contribution of the astronomy. Kasi, naalaman nila that the universe is expanding, okay, nag-lead yun para maipropose yung Big Bang Theory. Okay, or para mapagtibay pa or makapagbigay ng support about Big Bang Theory, which is the theory na pinaniniwalaan natin na doon nagsimula ang universe. Okay, so astronomy has impacted our lives through advancement in space, satellite technology, cosmology, astrophysics, and cultural heritage. Ang daming naging impact niyan sa atin. Okay, so yung development ng astronomy talaga, nagkaroon ng madaming advancement, even space travel, like what we are doing in Mars. Di ba nagpadala tayo doon ng expedition, the Perseverance rover, last 2021? Okay, so ano yung goal nila doon? Okay, to find remnants or a trace of life. Kung suitable ba ang Mars to be a habitable planet for us, di ba? Okay, but for me, in my own opinion ha, okay, syempre, ang science kasi, broad field. Okay, ito ay gusto nila lagi may discovery. Okay, hindi lang sila nag-stop in one point. But for me, in my opinion, why not? Bakit pa kailangan nilang i-rediscover ang Mars? Kung kailangan, kung nandito na sa ating harapan yung pinaka the best planet, which is the Earth, right? Okay, yung problem lang ng Earth is the global warming. Why not be unified, lahat ng nation, to address this problem? Para hindi na tayo maghanap ng iba, right? Okay, next. Okay, so let's start the third titles or topic, the development of astronomy. Okay, how astronomy developed. Ayan, so define muna natin kung ano ba yung science or the science of astronomy. So when we say astronomy, the scientific study of celestial objects and phenomena beyond Earth's atmosphere, involving observation, measurement, and analysis of their movements, physics, and chemistry. Ang dami nabanggit. Ano? So parang ang lawak ng field talaga ng astronomy. It's not like nandito lang tayo sa isang kahon. Malawak pa yan. Okay. So, sabi dyan, the scientific study of celestial object and phenomena beyond Earth's atmosphere. Ibig sabihin, pinag-aaralan nito yung mga celestial objects na nasa labas ng ating atmosphere. Outside, of course. Nakalampas na ng exosphere. Okay. And then, mga phenomena. When we say phenomena, occurrence, or events, mga notable events in the universe. Okay. Involving observation, of course, syempre, in astronomy, it involves in observation, measurement, analysis of their movements, physics, and chemistry. Ano ba yung main measure? Okay, syempre, in astronomy, ang daming mini-measure dyan. Mga circumference ng mga planets, okay, mga sizes ng mga asteroid, kung ano ba yan. Okay, and then yung mga distances. Okay. And analysis of their movements. Kaya nga nila na-track yung mga orbital period ng bawat planet. Kasi mineasure nila yun. It involves physics and chemistry, of course. Ayan. So, sinasabi, astronomy is a very old science. Do you agree with that? That astronomy is one of the field in science which is considered old. Okay, so the question is why astronomy is considered as very old science? Bakit? Bakit kaya matanda? Ano yung reason? Ano for that? So, for that particular question, we considered astronomy as a very old science, okay, because humans have been studying the stars and planets for thousands of years. Yun yung reason. Kahit noon pa, okay, wala pa yung word na astronomy. Okay, hindi pa na-discover kung ano man tawag. Nag-o-observe na ang mga tao ng mga stars and planets. Ginagamit na nila yon. Okay, for example, okay, kailan ba tayo right na magtanim ng mga ganitong plants? Kailan ba tayo dapat mangisda? After ba ng full moon or new moon? Okay, may ginagamit na nila yung knowledge nila in astronomy dati pa. Kaya kino-considered ang astronomy as a very old science. Okay, and the earliest astronomers were ancient civilizations such as the Babylonians, Egyptians, and the Greeks. Ito yung mga kino-considered natin as early astronomers talaga naman. Okay, so who made observations of celestial objects and developed theories about their motions and properties. So start tayo dito sa Babylonians. Okay, that starts in 1500 BC. Okay, what is the contribution of Babylonians in astronomy? Ano ba yung maging contribution ng mga Babylonians? Nasaan ba ang mga Babylonians? Okay, before we continue. Saan sila nag-emerge? In what particular part, okay, of our planet? Okay, in Asia, di ba, nasa ano sila? To be specific, in Mesopotamia, which is known as Iraq today. Okay, yun yung bansang Iraq ngayon. And then, okay, so ito na yung mga contribution ng mga Babylons. Made systematic observation of the night sky, recording the motions of celestial objects such as the moon, sun, and planets. Okay, nire-record na nila yung mga motions, okay, ng mga celestial objects dati-dati pa. Okay, so napapataka tayo, ano kaya nga ginamit ng mga instruments for that? May telescope na ba? Okay, so syempre in Babylons, okay, during that time is wala pa, 'di ba? Okay, so develop zodiac a system of 12 constellations that help track the movements of the sun, moon, and planets across the sky. Okay, nakadevelop sila ng 12 constellations, okay, that help to track the movements of sun, moon, okay, and planets across the sky. Okay, ano na yun? Di ba napaka-systematize ng mga Babylons? Next, develop a method of predicting eclipses Ba, nakadevelop sila. Okay nga naman ng method to predict eclipses, which is wala pa silang technology dati pa. Pero nakagawa sila ng way, di ba? Ang astig ng mga Babylonians. Okay, at ano naman yung method or what is the method that they use to predict eclipses? Okay, it is known as the Saros cycle. Ano ba yung Saros cycle? A period of approximately 18 years and 11 days. Okay, that's the Saros cycle, during which a similar eclipse pattern repeats. Abang astig naman ano. Next, develop a sophisticated system of astronomy based on a lunar calendar. Nakagawa din sila ng kalendaryo. Okay, ang galing ano. Ano ba yung pangalan or what is the calendar which is invented by the Babylons? Anong tawag doon? It is known as the lunisolar calendar. From the word itself, luni, which means lunar. Nakadepende sila sa moon. It was based on the lunar cycle but also incorporated adjustments to keep it aligned with the solar year. Okay. Yung lunisolar calendar nila may 12 lunar months, which is composed of 29.5 days each month. Okay, pero pag ni-round up naman natin yung 29.530 na din, ano, which is, ilan ba? Okay, yung days natin ngayon sa ating mga months. Diga minsan 30, 31, okay, and then February 28 lang. Okay, so, which is, ano naman, close. Okay, magagaling din. Next, ito po yung ating picture ng lunisolar calendar. Ayan. Next, well, the Babylonians did not have, or may question tayo, do Babylonians believe that the earth is flat? Naniniwala ba sila? Doon sa ibang reference ko kasi naniniwala daw ang mga Babylonians na earth is flat. Pero kung babalikan natin yung slide kanina, is nakadevelop sila ng method to predict eclipses, di ba? Pag nagkakaroon ng eclipse, ano ba yung shadow ng earth sa atin? Ng earth rather. Digat pabilog. So wala silang idea doon or wala talaga naman daw na sinabi ang mga Babylonians about sa shape ng earth. Sabi dito, while the Babylonians did not have a complete understanding of the Earth's shape and size, they were aware that it was a three-dimensional object and not flat. Pag sinabi nating flat, two-dimensional yun. Pero pag ang idea ng mga Babylonians, the shape of the Earth is a three-dimensional one. Okay, so, pero wala naman sila particular na sinabi kung ano talagang shape ng Earth. Okay, next. For example, Babylonians' observation of lunar eclipses and the positions of the stars and the planets suggest that they understood that the Earth was a sphere. Ayan. So, doon pa lang sa evidence natin or proof, talagang hindi talaga flat yung kailang observation or understanding about the shape of the Earth. Okay, so next. Proceed naman tayo sa mga Egyptians. Okay, ano bang ginagawa ng mga Egyptians na to? Ano bang ginawa nila? Okay, ng ating Egyptian or what is the contribution of Egyptians? Ayan. So one of the notable contributions of Egyptian, they develop a solar calendar. Kanina yung sa Babylonians, they developed the lunisolar, di ba? Dito naman sa Babylonians, Egyptians rather, they develop solar calendar, which is a very accurate one. Okay, na close talaga din sa ating calendar yung ginagamit ngayon. Yung solar calendar nila is based on the movements of the sun, consisting of 365 days, which is the exact days that we use in 1 year. Diba? It is divided into 12 months of 30 days each. Okay, napaka-close ano? Plus an additional 5 unlucky or cursed days. Okay, it is known as the Egyptian solar calendar. Ang astig nila, ano. Next, ito po yung ating picture ng Egyptian solar calendar. Hindi ko na-explain yung mga icons na yan. So, yung pinaka-simple explanation dyan sa mga icons na yan, they include their gods and goddesses in each of the representations na ginagawa nila. Okay, next. What is the contribution of Egyptian? Another, develop a system of observing and recording the movements of stars and planets, which is similar na din kanina sa Babylons, di ba? Nagre-record din sila ng mga movements ng stars, ng planets. Okay. Next, develop sophisticated mathematical and geometric techniques used in astronomy, architecture, and engineering, such as accurately measuring the circumference of the Earth and the angles of the pyramids. Okay, talagang ang mga Egyptians nakadevelop ng geometric techniques na kung titingnan natin yung mga pyramids na ginawa nila sa Egypt, perfect yung mga measurements. Which is, nakakapagtaka kasi wala pa silang mga technology during that time, di ba? pero accurate yung measurements nila. Kaya minsan, ina-associate yung mga Egyptian dati sa mga aliens, di ba? But it's not true or wala yung scientific explanation. Next, develop a system of observing and recording the movements of stars and planets, recognizing the appearance of certain stars and constellation and specific times of the year. Next, develop a system of timekeeping based on the positions of stars. Nakadevelop sila ng a system of timekeeping. Okay, na ano naman sa positions ng stars sa pag-ooras. Kanina yung sa Babylonians, nakadevelop sila ng method to predict eclipses, which is known as the Saros cycle. Ito naman, ang mga Egyptian, nakadevelop sila ng timekeeping method. Okay, nakabase naman ito sa positions ng stars. Ano ang tawag dun sa system of timekeeping? It is known as the stellar time. Okay, and what is a stellar time? Okay, it is based on the idea that the stars were fixed in the sky and could be used as a reference point for measuring time. Okay, kumbaga, ang pinaka-reference point nila to predict time is stars. Like for example, yung sun natin. Okay, kahit wala tayong oras na nakalagay sa kamay, di ba minsan ginagamit natin ang sun to predict the time. Okay, pag palubog na ang araw, parang ang ating intuition is that it's either 4 p.m. or 5 p.m. Diba? Yung ganun yung oras. Alangan maging 12 p.m. pa yon and palubog na nga. Okay, so next, the Greeks. Okay, so for the contribution of the Greeks, they developed the geocentric model of the universe. Ano ba yung tinatawag nating geocentric model? Okay, ito yung kumbaga dito talaga nagsimula sa mga Greeks, yung very notable or yung significant revolution in the field of science. Okay, the first one is the geocentric model, which is proposed by the Greek astronomer known as Ptolemy. Okay, siya yung gumawa niyan. Okay, he developed a model of the universe that placed the Earth at the center of the cosmos and the planets and the stars in circular orbits around it. Kumbaga dito sa geocentric model, ang sabi ni Ptolemy is, the Earth is the center of the solar system or even the universe. Which is, pag tinignan natin ngayon, is not accurate, right? But in science, we consider this model as a very important foundation of science. Kasi without it, we will not be able to come up in the right model that we are using right now. Okay, so yung opposite ng geocentric model is known as the heliocentric model. Okay, which is in heliocentric, which is proposed or recognized work of Copernicus. Doon sa heliocentric, sun talaga yung center ng ating solar system. But here in geocentric, remember that the Earth is the center of the universe. This model, known as the geocentric model, was widely accepted in ancient times until the Copernican Revolution in the 16th century. Nung nandun na yung Copernican Revolution, nagkaroon talaga ng significant or yung paradigm shift. Okay. Ito yung dati na pinapaniwalaan na bago. Okay. In this idea, talagang pinapatunayan na in science, all the theories or laws, it is considered as falsifiable. What do you mean by falsifiable? Okay, yung dati nating alam ngayon, na sa tingin natin ito yung tama ngayon, okay, pwede palang maging mali in the future. Ganun sa science. Next. Okay, so this is the illustration of the geocentric model. Okay, tingnan natin kung gaano ka haggard yung Earth na nasa center. Ang pangit naman tingnan. Next, the discovery of the precision of the equinoxes. Okay, the Greek astronomer Hipparchus discovered a phenomenon known as the precession of the equinoxes, which is a slow and gradual shift in the position of stars relative to the Earth's orbit. This discovery had important implications for the measurement of time and the development of calendar. Yung basic idea is that sa equinox, it is known as the equal length of day and night. Okay, so yun lang. Next, development of trigonometry. Aba, okay, the Greek talaga, palagan tayo pag pinapahirapan sa math, ang ating unang naiisip is the Greeks. Okay, so the Greek mathematician and astronomer Hipparchus developed the field of trigonometry, which is the study of the relationship between the side and angles of triangles. Trigonometry was essential for making accurate measurement of distances and angles in the astronomy. So, siguro, accidentally na lang nila na discover yung field ng trigonometry. Kasi, during that time, if they are observing the different celestial objects in the universe, ano ba yung kanilang minimeasure dyan? Okay, yung mga distance, circumference, okay, yung mga sizes ng bawat celestial objects. Okay, so siguro, through time na discover na din nila or tinawag na nila yung trigonometry. Next, the cataloging of stars and constellations. Okay, syempre pag nag-observe ang mga Greeks, they tend to list or they tend to record it in a certain book. Okay, so the Greek astronomer and mathematician Ptolemy created catalog of over 1,000 stars and constellations, which was used as a reference for astronomical observations and for centuries. Ang dami nilang na-record, 1,000 stars, 1,000 constellation. And mostly yung mga pangalan ng mga yan, mga stars and constellation, kinuha nila dun sa kanilang gods and goddesses in Greek mythology. Pinangalan nila. Like for example, Hercules, we have the Cassiopeia. Okay, so doon nila pinangalan. Okay, sa mga naka-associate kasi dati ang science sa religion. Kaya, siguro yun. Okay, next. The development of scientific method. Ang nag-introduce talaga sa atin ng scientific method is the Greek. Ano ba yung tinatawag nating scientific method? It is the systematic way, okay, for a certain theory to be accepted. Okay, yung mga pinopropose dapat ng mga ideas, hindi lang basta mo sasabihin na the earth is round. Okay, the sun is the center of the solar system. Hindi pwedeng ganun lang in science. You have to make a certain experiment. You have to make a proof, okay, that your claim is valid. Okay, so dapat may ebidensya ka, hindi lang yung sinabi mo na, ay, ito yon. Okay, you need to go in the process. Okay, in scientific method, we have the observation, the making hypothesis, the experimentation, and then after that, you need to arrive in a conclusion. Ganon. Okay, dapat systematic. Okay, next. Ayan, so throughout the history, there have been several different ideas about the shape of the earth. And here are some of the most notable ones. So, discuss naman natin. Tapos na tayo doon sa mga notable events or contributions of the Babylonians, Egyptians, and the Greeks. Punta naman tayo dun sa shape ng earth. Ano ba yung mga pre-post dati na shape ng earth? Okay, na-reject. Okay, so una, we have the flat earth daw, spherical earth, the oblate spheroid, the geoid, hollow earth, and the flat disk. Okay, so first one is the flat earth. Pag sinambit natin from the word itself, flat earth. Okay, flat. This idea is perhaps the well-known and posits that the earth is a flat, a two-dimensional plane. This belief was prevalent in ancient cultures including ancient Greece and Egypt. Okay, abang haggard naman. Tingnan natin yung picture or illustration about the flat earth. Okay, tingnan natin, parang pinggan lang. Plato, flat earth. So, na-reject naman siya. Dati pa, hindi siya accepted. The next one, we have the spherical earth. So, this theory, which is now widely accepted, posits that the earth is a sphere. This idea was first proposed by ancient Greek philosophers such as Pythagoras and Aristotle. Okay, sabi ni Pythagoras and Aristotle that the earth is a sphere or in round shape. Okay, so, lahat naman, hindi naman talaga perfect. Pag sinabi kasi nating sphere, pero perfect yung pagkakabilog niya. But our planet, it is archipelagic. May mga isla-isla yan, may mga bundok, may mga edges yan. Hindi yan perfect sphere. Hindi yan sobrang kinis. Okay, kumbaga, may mga edges, may mga irregularities. Kaya yung spherical earth na yan, na round ang earth, na rejected. Next. Okay, we have the oblate spheroid. Okay, yung oblate spheroid naman, ito yung tanggap na shape ng earth. Which is lagi namang natatanong ito pag may mga quiz B, what is the shape of the earth? Napaka-basic question yan. Okay, oblate spheroid, yung pinaka-sagot. Okay, so this theory posits that the earth is not a perfect sphere. hindi talaga perpekto na sphere or round ang Earth, but rather an oblate spheroid, meaning that it bulges at the equator and is slightly flattened at the poles. Okay, so this idea was first proposed by Sir Isaac Newton in the 17th century. Ito yung pinakatanggap na shape ng Earth, yung tinatawag nating oblate spheroid. Okay, so hindi kasi perfectong sphere. Kumbaga, ang oblate spheroid may associate natin sa oblong, parang oblong in the different shape or geometric shapes. Okay, parang kapag ganun siya. Next, the geoid. Okay, yung geoid naman po natin, this theory posits that the Earth is not a perfect sphere but rather an irregular shape known as geoid. This theory takes into account that Earth's gravitational field which causes slight variations in the planet's shape. Kumbaga, what do you call this? Paano ko siya i-explain? Yung geoid kasi natin, pag meron tayong circle, halimbawa may circle tayo, kumbaga may mga palubog, paumbok, ganun ang geoid. Okay. May mga irregularities sa kanya. And yung irregularities daw na yun is cause of the strong gravitational pull of our planet. Okay, parang hindi naman siya accepted din. Okay, again, what is the accepted shape of our planet? The oblate spheroid. Ayan. And then the next one, we have the hollow earth. Okay, ito yung hollow earth. This theory posits that the earth is not a solid sphere but rather a hollow one. Okay, it is proposed by Jules Verne and has been subject of many conspiracy theories. Okay, so hindi rin kasi siya accepted kasi sabi dito, ang ating Earth may butas daw sa South and North Pole. Okay, so ganun yung idea ng hollow Earth. Kaya hindi rin siya natanggap. Okay, next. The last one, we have the flat disk. Kung nakakita naman tayo ng CD, okay, ganun daw yung shape ng ating planet. Okay, some cultures such as some indigenous groups in the South America and Africa have believed that the Earth is a flat disk rather than a sphere. Okay, which is napaka weird naman tingnan ano. Disk, CD, parang CD type. May ilalim at may taas. Okay, so next, proceed na tayo sa astronomical phenomena para mabilis tayo. So there have been countless of important astronomical phenomena throughout history, but here are 5 significant events. 4 lang pala yung nilagay ko. 4 significant events. Ayan. So we have formation of the solar system, supernova explosion, Galileo Galileis, and the Mars Perseverance rover. Unahin natin yung formation of solar system. Ito naman ay na-discuss na natin. Kumbaga, hindi na natin ito masyadong i-focus. Na-discuss na kasi natin yung Big Bang Theory in the 3rd quarter, right? Okay, so yung formation ng planet natin or solar system about 4.6 billion years ago or happened about 4.6 billion years ago. Okay, na nag-expand yung ating universe through Big Bang Theory. Next, supernova explosions. Ayan, ito yung pinaka isa sa mga astronomical phenomena. Fascinating one. One of the famous supernovae was the SN1054, which was observed by the Chinese astronomers in 1054 AD. Ang tagal na. And is now known as the Crab Nebula. Okay. Pakitandaan na lang So, ito yung pinaka-famous na supernova. Pag sinabi natin supernova, the end point of the star's life cycle. Next, Galileo Galilei's observation. Okay, ang daming ng mga observations ni Galileo Galilei pero naglagay lang ako dito ng mga notable observations niya, including the phases of Venus, the moons of Jupiter, siya din yung nag-observe ng mga yan. The craters of the moon, 'di ba? Ang moon natin, may mga parang craters yan, yung parang tingin natin butas-butas. Okay, but yung mga craters na yan, it's parang yan yung may mga bumagsak na mga meteor sa kanya, tumama. Okay, kaya nagkaroon siya ng mga ganong craters. Aside from that, the observation provided evidence for the Copernican heliocentric model of the solar system and revolutionized our understanding of the cosmos. Yung observation din ni Galileo Galilei, tumulong siya kay Nicholas Copernicus para mas mapagtibay yung kanyang idea about heliocentric model or the model wherein it suggests that the center of our solar system is the sun, not the earth. Okay, next. Ayan. So, last na po natin sa astronomical phenomena is the Mars Perseverance rover. Na kung matatandaan natin noong February 2021 nga, nagpadala, okay, ng expedition ang NASA or the National Aeronautics for Space Administration. Okay, so yung ating NASA, nagpadala sila ng expedition in the red planets para ma-observe, okay, yung kanyang structure or yung surface. Ano ba yung goal ng Mars Perseverance rover? Okay, yung kanyang mission, yung pinaka-goal niya is makahanap ng traces ng microbial life or trace ng life itself sa Mars. Kung possible ba na maging habitable yung Mars. Okay, similar sa ating planet. And aside from that, ang expedition na yon, yung goal ng Mars or Perseverance rover is to collect and store samples of rocks. Ano ba yung mga sa mga rocks? Mga minerals. Okay? And solve for future return to Earth. Okay, so yun yung ang goal ng Perseverance rover. So, I want you to watch this video or news about the exploration of Perseverance rover in Mars. Okay, so ito po yung Perseverance rover natin. Ayun, so panoodin natin tong video. Ayan. So, kung nakita natin, napanood naman natin sa video, we really know na yung adventure or yung expedition ng Perseverance rover is to collect microbial life or traces of life in Mars and then to collect samples of rocks. Pero, di ba na napanood natin sa news, may isang Pinoy na kasama dun sa expedition na yun. And ang taas ng position niya. Okay, di ba? Engineer. Isa sa mga gumawa or pasinayan ng expedition ng Perseverance rover. Next. Okay, so knowing the different stages of astronomical development is important for several reasons. Understanding the origins of the universe by studying the different stages of astronomical development, we can gain insight into the origin and evolution of the universe, including the formation of stars, galaxies, and the planetary systems. Explaining current astronomical phenomena by understanding how astronomical objects and systems have developed over time. We can explain current phenomena such as the motion of planets, the behavior in stars, and the structure of galaxies. Punta naman tayo dun sa development ng astronomy. Paano ito nagsimula at ano na ba yung pinaka-structure or pinaka-framework ng astronomy today. Okay, so it starts in 3000 BCE. Okay, in ancient civilization in Mesopotamia or also known as the modern-day Iraq. Okay, ang tawag na ngayon sa Mesopotamia is Iraq. Okay, aside from Iraq, the Egypt, China, and Central America begin observing and recording celestial events, including the movements of the sun, moon, and the stars. Okay, diba sabi ko nga, even in ancient times, they already start recording, observing the movements, okay, of the heavenly bodies or celestial objects in the solar system or in the universe. Next to it, we have 3000 BCE again, ancient civilization. Okay, so similar. So ito yung mga artifacts na nakuha. Okay, or a proof that these civilizations really observe the movements of stars and celestial objects in the solar system. Next, 310 BCE. Okay, the Greek astronomer Aristarchus proposes the heliocentric model of the solar system in which the sun is at the center of the earth and other planets orbit around it. So, in the 10 BCE, si Aristarchus talaga yung nagpasimula ng heliocentric model. Okay, pero sabi nga dati, hindi ito na tanggap. Okay, or na-ignore lang that time. Okay, kumbaga kung titingnan natin, siya yung nagsabi, pero iba yung nag-credits. Kumbaga ako yung gumawa, iba yung na-awardan. Okay, ng kanyang notable contributions. Okay, so in 310 BC, a Greek astronomer Aristarchus proposes the heliocentric model of the solar system, in which the sun is at the center and the earth and other planets orbit around it. However, this idea was not widely accepted at the time and was largely ignored until Copernicus revived it in the 16th century. Okay, so what do you think is the main reason why the idea of what do you call this? The idea of Aristarchus is not accepted. Okay, so what do you think is the main reason for that? Okay, so the idea of Aristarchus is not accepted during that time since in that period of time, the religious or the field of religion totally embodies a certain country. Kumbaga, ang namamayagpag na field dati is religion, not science. Okay, ano ba yung idea natin sa religion dati? Okay, si Jesus Christ ang gumawa ng universe, ng mga planets. Okay, or nag-create ng universe. So, it means kung nandito tayo sa Earth, ang thinking ng tao, God made the Earth as the center of everything. Okay, yung thinking nila ay ganun, which is not correct. Okay, so, until such time na nandun na si Copernicus, na bago yung idea ng geocentric, which is na-introduce na ulit or na-revive yung idea ni Aristarchus. Okay, next. Ito po yung ating heliocentric model. Ayan, so next, in 1543, a Polish astronomer Nicholas Copernicus publishes the Revolutionibus Orbium Caelestium. Ito yung book na pinublish ni Nicholas Copernicus, which proposes a heliocentric model of the solar system and marks the beginning of the scientific revolution. Pero bago pa, hindi ko lang na-list dito. Bago pa si Nicholas Copernicus. Yung idea din niya is nakuha niya kanino kaya niya nakuhang scientist. Okay. Bibigyan ko kayo ng time. Okay, you need to put your answer in the comment section. Sino kaya yung scientist na tumulong din sa idea ni Nicholas Copernicus about the heliocentric model? Okay, anyone? Okay, wait tayo sa comment section. Okay, so yung ating sa astronomer na tumulong din kay Nicholas Copernicus, not totally tumulong. Okay, kasi ito'y patay na before pa makapag-propose si Nicholas. So, ang nag-propose po niyan is si Tycho Brahe, a Danish nobleman astronomer and alchemist who made significant contribution in astronomy. Kumbaga si Brahe, okay, ang ginawa niya is nag-inobserve din niya or siya din ay nag-propose, okay, ng idea about heliocentric model. Next, 1610. Okay, the German astronomer Johannes Kepler publishes Astronomia Nova, which introduces his laws of planetary motion and provides a more accurate mathematical description of the motions of the planets than either the geocentric or heliocentric models. Itong si Johannes Kepler, ang pinapropose niya is yung three laws of motion, which is yung the law of ellipses, the law of harmonies, and the law of equal areas. Okay, and then yung mga laws na yan, na tumulong din yan, okay, para mas maintindihan ni Sir Isaac Newton yung three laws of motion, which is the law of inertia, law of acceleration, and then the law of action-reaction. Okay, so next, in 1687, English mathematician Sir Isaac Newton publishes Mathematical Principles of Natural Philosophy, which introduced the laws of motion and gravity and helps explain the motion of celestial bodies. He also develops calculus and makes many other contributions to physics and mathematics. Ayan, so sinabi ko na nga kanina, after ni Johannes Kepler. Ayan. So, natulungan yung idea ni Sir Isaac Newton about the three laws of motion. Okay. Parehas three laws of motion. But yung kay Kepler's kasi three laws or the three planetary motions. Okay, yun yung kanyang may planetary. Yung ano naman ni Sir Isaac, three laws of motion ng mga objects. Okay. Next, 1915, Albert Einstein publishes his theory about general relativity, which revolutionizes the understanding of gravity and its effects on space and time. This theory helps explain many previously unexplained astronomical phenomena, such as the precision of the orbit of Mercury and the bending of light by gravity. Okay. Next, in 1929, American astronomer Edwin Hubble discovers that the universe is expanding, providing evidence for the Big Bang theory of the origin of the universe. He also develops the concept of the Hubble sequence of classifying galaxies and makes many other important contributions. So, itong si Edwin Hubble, kung babalikan natin sa third quarter, ano ba yung ginawa niya? Okay, siya yung ka-discovers that the universe is expanding. Ano ba yung mga na-provide niya na idea? Okay, about the Big Bang Theory. Yung idea niya about the redshift, about the CMBR or the cosmic microwave background, and the abundance of elements. Okay, next, the Kepler's laws of motion. So, ito na tayo, the last part. Ayan, so the law of ellipses, the law of equal areas, and the law of harmonies. Medyo super bilis tayo. Ano, what time na ba? Okay. So, for the first law, the law of ellipses, each planet orbits the sun in an ellipse, which the sun at one of the two foci of the ellipse. The shape of the ellipse is determined by the eccentricity of the planet's orbit, which is the ratio of the distance between the foci to the length of the major axis of the ellipse, where the eccentricity is zero. The ellipse becomes a circle. Okay, ito yung law of ellipses po natin. Okay, na yung ating mga planets, okay, nag-orbit around the sun. Okay, in an ellipse. Okay, di ba yung shape nga, elliptical shape, yung mga shape ng orbit ng mga planets. Okay, next, we have the law of equal areas. A line joining a planet and the sun sweeps out of equal areas in equal intervals of time. This means that when a planet is closer to the sun, it moves faster, and when it is farther away, it moves slower. This law can be thought of as a statement of conservation of angular momentum. So, doon sa law of equal areas, okay, alam naman natin na may mga certain distances ang bawat planets or celestial objects na meron sa solar system. Okay, so sa paglayo ng mga celestial objects sa sun, sa pagbagal ng ikot, sa paglapit, sa pagbilis. Okay, yun yung idea ng the law of equal areas. So, titingnan natin yung mga orbital period ng ating mga bawat planets. May picture ako dito. Okay, ito yung mga orbital period natin. Sa Mercury, 88 days. Makakomplete siya ng isang revolution, 88 days. Which is napakabilis. Sa atin naman, 365 days. Yung pinakamatagal na ikot, yung Neptune, which is 165 years. Kasi siya yung pinakamalayo. Bago pa siya makaikot, nakailang ikot na tayo. Okay, next. The last one is the law of harmonies. The square of orbital period of a planet proportional to the cube of the semi-major axis of its orbit. This means that the farther a planet is from the sun, the longer its orbital period. The constant of proportionality is the same for all planets in the solar system, and it's known as Kepler's constant. Okay. Ayan. So, may mga kanya-kanyang orbital period nga yung bawat planets. At sinasabi ko hindi lang po planets ang may orbital period. Even the asteroid, the comets, may mga orbital period din po sila. Paglapit, which is nandun sa law of equal areas, paglapit, pagbilis. Paglayo, pagtagal ng ikot. Okay. Ayan, so that's ends with our discussion. So, prepare for a short quiz. Send ko na lang yung Google form sa ating group chat. And the quiz will be taken for at least 30 minutes lang. And then after 30 minutes, I will close the Google form. And then, okay, after that, if you already accomplished the task, you may now take the remaining time as your vacant. Pwede nang gawin yung mga gusto nyong gawin. Okay. So, thank you again and have a nice day.